So, hello everyone. This is the ninth video lecture in the data science series, and in the ninth lecture, I am discussing about regression modeling. In regression modeling, first is estimate model evaluation using a Python. Now, discussing about why would model evaluation matter, and some in the depth of the model. Access model performance. It allows to us to understand how we will our model perform on unseen data and make informed decision about its efficient. Identified area and improvement. By evaluating our models, we can pinpoint areas where it is struggles and implementation adjusting to enhance its accuracy and reliability. Now, second one is a common evaluation matrix: accuracy, precision, recall, F1 score. The proportion of correctly classified intentions. The ability of a model to correctly identify positive instant. Recall. The model ability to find all the positive instant. F1 score is a harmonic mean of precision and recall, providing a balanced measure. Now moving forward and discussing about splitting data from a evaluation. Train, test, split, divide data into training and testing sets to train the models on one set and evaluate its perform on the other. Cross validate, split the data into multiple folds, trains the models on the subset and test on the remaining float. Rotating to the obtain robust and estimates. Now, implementations cross validations, k-fold cross validations, stratified cross validations, leave one out cross validations. Now, k-fold cross split the data into k-folds and iterate through them. And stratified cross validation is ensured that the inner fold maintain the same proportions of classes. Leave one out. Is all about instant of a training evaluations on the remaining instant resulting. Now moving forward is a visualization. Evaluation result is a confusion matrix, confuse through ROC curve, precision recall curve. Now hyperparameter tuning. Grid search. Evaluations of a predefined grid of a hyperparameter value. Second one is a random search. Randomly sample hyperparameter values. Third one is a Bayesian optimization. Use past evaluations of a guide the search of a optimal hyperparameter. Now moving ahead is what is a stepwise recognition, automate feature selections, iterative process. Stepwise recognition is a statistical method that semantically added or remove predictors variables from the recognition models. And iterative process is involve additions or removing variables one at a time, accessing their impact on the model perform and making decision based on predefined criteria. And pre-require requests and assumptions, linear relationship, independent variable, sufficient data, normal distributions. Stepwise regressions assumes a linear relationship between the independent variable and the dependent variable. Independent variable is the predictor variable should be independent of each others to avoid multicollinearity. Sufficient data have a sufficient number of data points in a crucial for an accurate model build and evaluations. Normal distribution. The dependent variable should ideally follow a normal distribution. Now, preparing the data is a data collection, data cleaning, data transformation, data splitting, gathering relevant data and ensure it accurate and completeness. Now, some hand data cleaning, handle missing values, outliers, and inconsistency. Data transmission is basically applying transmission if necessary to meet the assumption of the regression. Data spacing is divided into a training and a testing sets for the model evaluations. Now, implementation of a stepwise regressions is a Python libraries, forward selections, backward eliminations, stepwise algorithm. Now, evaluation the model is a R squared and p value, and the p and mean square errors and adjusted R square. Now, interpreting the results. Firstly, is coefficient, p-value, model significance. In a coefficient, indicate the direct direction and magnitudes of a relationship between each variables and depend variable. P-values determine whether the variables are satisfied significant in the model. Third one is the axis, the overall significance, the model and its ability to predict the dependent variable. Now, applications and uses and causes, predictive modeling, feature selecting, model optimization, data analysis. In a predictive modeling, predictive features outcome such as a scale, customers, charms, and diseases risk. Second one is the feature relations, identifying the most influential variable for a large data sets. Proving the accuracy and efficiency of a reason model, gaining insight into the relationship between variables and their impact on their depend variable. So, all about today videos. This is a model estimate model evaluation using a Python, and hope you like and learning the video. And thank you for